In this video, we will cover a few errors that you can debug with the Pocket NC simulator. First, we'll go ahead and upload the part that is considered in the first part tutorial, which is a cube with some shapes cut into it. We won't upload a model to go along with this code in this instance. As we navigate over to the summary pane, we'll see an error pop up here around line 21,000. And since the program is around 21,000 lines, the error is towards the end. So we'll go over to the Gcode and scroll down to the bottom. When there is an error in the code, a red X displays in the column to the left of the Gcode. When there is an error in the simulation, the machine will turn red as it plays through the error as shown here. Going back into the Summary tab, we read the error we're getting, which is a fairly common error that an axis limit has been exceeded. It's easy to fix this error by changing the tool length offset, and the simulator actually recommends to extend the tool length offset by 0.1723 inches. Scrolling down, we'll see that the default value for tool length offset is stored. If we've previously measured the tool length offset, we can enter that value in, or if we haven't measured the tool length offset, we can change the value such that we no longer get this error. We'll go ahead and change this value by pressing the stop button. Be sure to press enter to store the value, and then reload the code with the new tool length offset. Upon reloading the program, note that the error has gone away and we can play through the simulation. For this next example, we'll return to the spiral and upload both the code and the model. Moving over to the summary pane, note that there are no errors reported. However, when we go to run the simulation, notice that the tool paths do not line up with the stock. And as the simulation plays, it seems that the tool is not making contact with the stock. This is also a pretty common occurrence, which is that the work coordinate system has been incorrectly set. So if the machine were running, it would be machining air instead of coming into contact with your part. To fix this, you'll need to go back into the cam and properly set the origin. In this example, you'll want to make sure that your model has loaded correctly and that it is in fact the Gcode having the issue. In either case, something isn't matching up, so it's worth looking into. In this particular example, it is the tool paths that have an incorrect origin, as they're not centered about the B table as the model is. Note that in this example, there was no obvious error in the Summary tab, so it's important to run the simulation through and make sure that the tool paths that run are what you expect. At times, there can be errors that come up when the cam is post-processed, so this simulator should help uncover some of those issues before running the code on the machine. These two examples are errors that you can find with the simulator. We hope that you find this a useful tool to debug some of your code. Please feel free to share your experience and feedback.